Assalamualaikum everyone. So first we need to know what is renewable energy. Renewable energy refers to energy that is collected from resources that are naturally replenished on a human timescale, such as sunlight, wind, rain, tides, waves, and geothermal heat. Unlike fossil fuels, which take millions of years to form and release harmful emission when used, renewable energy sources are abundant, sustainable, and eco-friendly. With the growing need to address climate change, reduce greenhouse gas emission, and ensure energy security, renewable energy has become a vital part of the global energy landscape. It offers a cleaner, more sustainable alternative to conventional energy sources, enabling societies to meet their energy demands while protecting the environment. By harnessing the power of nature, renewable energy technologies are paving the way toward a future where energy is not only accessible and affordable but also sustainable for generations to come. This makes it a cornerstone of efforts to achieve a greener, more resilient planet. Next, we move to the significance of renewable energy. First, it can give health benefits. Cleaner energy resources reduce air and water pollution, leading to significant public health benefits. Fewer pollutants in the environment mean fewer respiratory and cardiovascular disease. Next, energy independence. The global nature of the renewable energy transition promotes international collaboration with countries sharing knowledge, technologies, and investment. This cooperation helps to build a unified approach to global challenges like climate change. And lastly, economic growth. The, the renewable energy sector fosters innovation and creates jobs in manufacturing, installation, and maintenance. Investment in renewable infrastructure stimulates economic growth and promotes sustainable development.
Hi, Assalamualaikum. My name is Muhammad Azib Shambiasan. I will talk about basic principle involved and how it works. Firstly, we have solar energy. That means relies on the photovoltaic effect, in which is sunlight excites electrons in semiconductor material to produce an electric current. Is the basis for solar energy. And concentrated solar power system use thermodynamics to generate electricity by heating a fluid with sunlight to create steam that powers turbines. Secondly, we have wind energy. Wind energy uses turbines to transform the kinetic energy of moving into the mechanical energy in order for turbine blades to efficiently collect energy from airflow. And next, the concept of conservation of momentum and Bernoulli principle are essential to their design, which is wind energy. Thirdly, we have hydroelectric energy. Hydroelectric power generates electricity by using the gravitational potential energy of water stored at height, which is changed into kinetic energy as the water flow lower and power turbines.
Alright, now I want to talk about example of energy conversion technologies. So we go through to solar energy first. For the first one is photovoltaic solar cells. For the function is convert sunlight directly into electrical energy using the photovoltaic effect. For the example, PV solar panels commonly used on rooftops or large solar farms. For the second one is perovskite solar cells. For the function, a new type of solar cells that use perovskite semiconductor materials to convert sunlight into electrical energy at a lower cost and high efficiency. For the example is perovskite solar cell are currently in the development and commercial trial phase. Alright, next we move to example of energy conversion technologies for wind system. The first is onshore wind turbines. For the function, use the kinetic energy of the wind to move turbine blades, which then drive a generator to produce electricity. For the example, onshore wind turbines farms, such as those found in the open areas with consistent wind speeds. For the second one is offshore wind turbines. For the function, similar to onshore wind turbines but installed offshore or onshore in areas with stronger and more consistent winds. These turbines are larger and produce more energy than onshore turbines. Example, wind turbines from built in ocean water, such as the Hornsea offshore wind farm in the UK. Alright, this is the last example of energy conversion technologies, which is hydroelectric. First, we have reservoir hydroelectric plants. For the function, water is stored in a dam or large reservoir and released through turbines to produce electricity. This system produces energy as needed by controlling the flow of water. For example, Hoover Dam hydroelectric plant in the United States. So the second one is wave power plants. For the function, use the movement of ocean wave to generate electricity. This system use technologies such as floating buoys that are pulled by wave to drive generator. For the example, wave energy projects such as wave power generation floating buoys have been tested in several coastal areas.
So for the next topic, we will be talking about potential benefits and challenges in renewable energy source. In today's rapidly evolving world, the pursuit of renewable energy has become more important than ever. As we strive to reduce our carbon footprint and mitigate the effect of climate change, renewable energy technologies have emerged as a promising solution. Among the various advancements in this field, the utilization of magnetic materials have proven to have a significant impact on the efficiency and effectiveness of renewable energy related technologies. Potential benefits. The first one is magnetic generators. One of the most prominent renewable energy source is wind power. Wind turbines, which convert the kinetic energy of the wind into electricity, rely on the use of magnetic materials in the generator. These generators typically consist of permanent magnets and electromagnets that work in tandem to produce electricity efficiency. The next one is magnetic field sensor for solar tracking. Solar power, another prominent renewable energy source, heavily relies on magnetic field sensor for accurate sun tracking. Solar panels equipped with magnetic field sensors can precisely detect the position of the sun and adjust themselves accordingly, maximizing the absorption of solar energy. And this dynamic sun tracking ensures that the panels are aligned optimally, resulting in increased electricity production throughout the day. And the last is magnetic materials in hydropower generation. In hydroelectric power plants, turbines are coupled with generators that contain powerful electromagnets as water flows through the turbines. It causes them to rotate, activating the electromagnets. This movement induces a current in the electromagnets, which is then converted into electricity. The utilization of magnetic materials in these generators enables efficient energy conversion, contributing to the sustainability of hydropower as a renewable energy source. And after that is challenges. The first one is intermittency. One of the main challenge of renewable energy is its intermittency. Solar and wind power generation is dependent on weather conditions, leading to the fluctuations in energy output. This can make it difficult to integrate renewable energy into the existing grid, which relies on a steady supply of electricity. For the second one is grid integration. Grid integration is also a complex issue for renewable energy. Integrating variable renewable energy source into the existing grid requires substantial infrastructure investment and advanced technologies to manage fluctuations in power supplies. And for the third one is energy storage for renewable energy integrations. Energy storage plays a crucial role in the integration of renewable energy source. As the renewable energy is variable, energy storage system provide a means to store the excess energy for the later use. Solar and wind resources are often located in remote area, far from the population.
centers where the energy is needed. The requires this requires the development of an extensive transmission infrastructure to transport the generated electricity from this remote location to the urban area. That's all for me. Thank you.
So I'm gonna talk about how renewable resources will develop in the future. First is renewable world. One study in the collection examine global warming, air pollution, and energy insecurity will create a Green New Deal roadmap for 143 countries to address these challenges. The new roadmap will be responsible to 99.7% of global CO2 emission to switch to 100% clean renewable wind, water, and solar power no later than 2050, with at least 80% renewable by 2030. Switching to wind, water, and solar power worldwide could possibly eliminate 4 to 7 million deaths caused by air pollution annually, while first slowing it and then reversing the effect of global warming. Finally, the energy demand could match the supply needed between 2050 to 2052, and after that, it's possible to power the planet entirely by sustainable energy. Next, by using the renewable resources, we could move away from using oil. According to another study, Saudi Arabia can transition to a 100% renewable energy system by 2040, and by 2050, solar power could account for 79% of the country's energy demand, supported by enhanced battery and water storage solution to lower energy system costs. The energy storage will play in the transition to a sustainable energy landscape to overcome the intermittent nature of solar and wind resources and provide power when there is no wind or sunshine. So lastly is a greener future. To be sure there is a challenges exist and target are ambitious, the report all conclude that the technology exists for the world to transition to a fully sustainable energy system by 2050, which should keep the planet below the 1.5 degree Paris global warming target. Mitigating the impact of climate change means fewer flood, storm, drought, and other extreme causes by warming temperature. It could also mean less pollution. Pollution is largely from burning fossil fuel, kills up to 7 million people annually, with low and middle income countries carrying the highest burden. The future powered by wind, solar, and other sustainable energy sources could also reduce energy bill, since the cost of producing wind and solar have plummeted in recent years. So, in conclusion, the future of renewable energy is promising, driven by technological advancement, declining costs, and growing global investment. As solar, wind, and energy storage technologies improve, renewables are becoming increasingly cost competitive, offering cleaner, more efficient alternatives to fossil fuel. Policy support, including climate agreement and incentives, will be crucial to accelerate this transition, while decentralized energy system and smart grid enhance energy security. The shift to renewable will help reduce carbon emission, create jobs, and foster sustainable economic growth. However, challenges such as infrastructure update, energy storage, and the social impact of transitioning from fossil fuel still remain. Overall, with continued innovation and collaboration, renewable energy has the potential to power a sustainable, resilient future. And that's all from us. Thank you.